cats and rabbits who reside in and get dressed in shoes and hats and trousers. In a world of my own, all the flowers. I wouldn't be here. There's just trouble with me. I give myself very good advice, but I very seldom follow it. That explains the trouble that I'm always in. Be patient is very good advice. Cats and rabbits who reside in and get dressed in shoes and hats and trousers. In a world of my own, all the flowers. I wouldn't be here. There's just trouble with me. I give myself very good advice, but I very seldom follow it.
Of course, he's mad too.
But I don't want to go among mad people.
Oh, you can't help that. Most everyone's mad here.
Folks, you know what time it is. By the way, I am the discombobulated voice of Coach East. I'm not actually Coach East. I am Coach East's id and stream of consciousness combined into one, which I guess if you think about it is actually me as a person. Anyways, moving on. Before we get into the main event, some quick announcements. Tomorrow night, we have the Gucci Home Lab show, which is my labor of love. Now that fake Jeremy has abandoned me to go live down in Mexico and run whatever it is he's running down there. I'm going to be talking about all the various systems on a chip you can put into your home lab. Now that the Raspberry Pi has gone the way of the dodo bird and the McRib at least 5 times a year. With that, you can hear more about the announcements for Temple stuff, because I understand we have some outsiders watching. The announcements for the Temple will continue more tomorrow evening, but with that, I'll bring it into the main event. I'm not saying that the hurricane didn't hit Tampa because of her, but the hurricane didn't hit Tampa because of her. So there's a tradition here in Pasco County where, you know, my beloved Pasco County, where we shoot at hurricanes and it scares the hurricane away. Dr. Sunny shot at the hurricane and it ran away, and, well, she spared us. So, you know, if you don't have a copy of her book on Burp Suite, you should buy it. If you do have a copy of her book on Burp Suite, you should buy another one. Why? Because you get the opportunity to give her money. Like, I can't think of a better opportunity. You have money. She wants it. Buy an extra copy of her book. Buy 3. Ladies and gentlemen, I present to you the immortal Dr. Sunny.
Welcome, everyone. Welcome tonight to part 2 of Attacking OAuth 2.0. So from the slide, you can see we're going to step right into where we left off last time. There probably would be a part 3, which we haven't determined when the date will be for that. So stay tuned for that. What I'm going to do is I'm going to go ahead and jump forward to where we left off. So in part 1, we talked about the implicit flow, which is a deprecated grant type. Now we're going to talk about the authorization code flow, which is probably the most popular grant type of OAuth. So what exactly is this flow? I'm going to use this as an example to sort of step you through, and then we're going to look at how it actually plays out as we go through the labs together. So as you can see, I'm going to grab my pen here. So as you can see on the left-hand side, this particular box shows an Android phone, but obviously this can be any client. So SPA, single page applications, could be mobile, could be anything. And the initiation of this exchange is between the client and some sort of authorization server. So I'm just going to call this AS over here. So the authorization server could be owned by the actual company that you're trying to get permission from. So the client is going to make a request against an endpoint. Now, in this case, the endpoint is /OAuth/authorize. There actually isn't any kind of steadfast, hard rule about what you call that endpoint. But most common conventions, you will see the word OAuth in there. Or usually authorize, or it could say OAuth login or something like that. And the whole idea is to initiate this exchange in order to get permission to access your resources. So, so what happens is we go through this initial exchange to the authorization server. Now there are going to be some key parameters that are sent in that initial request. The response type is code because this is the authorization code grant type. There's going to be a client ID. The client ID and the client secret. These are things that were made out of band. They were provisioned before this exchange could ever occur. Realize that if you're doing like a pen test, particularly on mobile apps, for some reason, I seem to see this a lot where you see the client secret. That's not good. You need to either turn that in for a bug bounty or write that up in your report. So client secrets need to be hidden, and they shouldn't be plainly seen like in Android manifest.xml or a plist file in iOS. So make sure that you write that up. What should happen is the developer should be placing those something that sensitive inside of either the key chain, like in iOS, or Android has something equivalent. So,
Dr. Sunny, could I ask a question?
Absolutely.
So if I found those secrets, how would I know what I was looking at, and how would I know that there's something sensitive there?
So the client secret, it's always going to be client_secret. That's kind of it's kind of like this client_ID that actually never changes. That's just the conventions of OAuth. So you would just look for that. And you would know in the flow, as you look at the traffic, you would know if the client is performing OAuth 2.0 authentication and authorization. But yeah, if you're pulling up the APK inside of Android Studio and you look at the Android manifest.xml, and I've seen it several times. You just look there and it's like, oh yeah, there's the client secret. So they need to be protecting that. The developers need to be protecting that. So hopefully that answered the question. So we'll go ahead and keep moving. Now there's another parameter, redirect URI, and we're going to see these parameters over and over again. So don't feel like if you miss something here, you're going to miss out, because we're going to talk about these parameters in the labs as well. But the redirect URI is what where the client is to return back to, which is generally the application that's asking for permission. So what happens is the authorization server takes these parameters, does a validation, says, okay, yes, I know this client. Yes, they have the secret. Yes, okay, I'm going to give you an authorization code in order to allow you access to whatever these resources are. So then that client application can take that authorization code, which is a one-time code. This is another area where you really should be testing. It's a one-time code. They're going to send back in the parameters, what the grant type is, its authorization code, the redirect URI, the client ID. And in exchange for giving this code back, the authorization server is going to give the access tokens. And the access tokens are the keys to the kingdom. So one of the things that you should be either pen testing or testing on your bug bounties is authorization code reuse. Have I found this on penetration tests? Absolutely. So it says right in the RFC, so if you read the OAuth 2.0 RFC, which I know may not sound like riveting reading, but there's some really good stuff in there. And it makes it explicitly clear that an auth code can only be used once. So if you're able to send that to repeater and over again, you keep getting access tokens, you've got a finding. All right, so I'm going to step you through the same auth code flow, but just in like a more concrete scenario so that you all can relate to what is happening. So we have this fake site called yourtwitterreader.com. So you're going to visit this and they're going to have a button there that says integrate with Twitter. So this site, your tweet reader, it's going to send a request to twitter.com and it's going to ask if you're going to authorize that application, that client application, your tweet reader can access your tweets. And that request is going to look like this. So you can see it goes against twitter.com. The response type code, am I showing the right, am I displaying the correct slide? Can someone confirm?
Yes.
Okay, perfect. All right. So you can see it goes against twitter.com and there's the client ID. So this client ID is something that is shared. It's established out of band between the client app and in this case, twitter.com. It's not secret, so it's no big deal. The redirect URI, scope, and a state. We'll talk about the state in just a moment. And then what happens is the end user is prompted with like a pop-up screen and it says, hey, do you authorize this? Do you really want to share your tweets with your tweetreader.com? So you have to give the consent. You can say yes or no. Most of the time we say, yeah, sure. So what happens is once accepted, then Twitter is going to send a request back to the redirect URI, which in this case is your tweetreader.com. And it's going to have that authorization code and it's going to have a state. Now, the authorization code, as we saw in the previous flow, that's what's used to basically exchange back with the authorization server for an access token in order to actually make the API calls. The state parameter is something of a mitigation against cross-site request forgery attacks. So this is something that the client application is supposed to check between calls to make sure that there was no tampering in between all of the back and forth. So once your tweetreader.com has that code, they can then ask for the access token from the auth server. Finally, once they have that, then they can use that access token to perform basically all functions available that twitter.com makes available. So reading your tweets and things like that.
Dr. Sunny?
Yes.
So is there any rhyme or reason as to the string that code or state is issued, or is it all just randomized, or is it a UID?
It should be a nonce, so it should be unique. It should be, don't quote me on this, but I believe it should be cryptographically secure. So you shouldn't have like a collision, because Yeah, for each request, the state should be unique because you can have multiple requests, of course, and you don't want to have the same value. So yeah, I would think it'd have to be cryptographically secure.
So if I catch them reusing state code or state strings, that's a finding.
That would be a finding. That would be the same as, and this of course is taking it into a completely new OAuth flow. But that would be the same as reusing an anti-CSRF token, which would be very bad. So yeah, that would definitely be a finding. Very good. I wanted to touch on OpenID Connect because OpenID Connect is very popular, very, very popular. So basically, it's a framework, and it's a framework that runs on top of, I'm just looking for my pen here. It runs on top of OAuth 2.0. Now, there are some distinct characteristics where when you're looking at some traffic, you're going to know if it's using OpenID or not. For example, there's always going to be this endpoint that's called .well-known/openid-config. There's nothing wrong with exposing this information. In fact, it makes our jobs a lot easier. It's designed to publicly make available all the endpoints that developers on the outside need to know in order to call this site. So it'll have on there the login endpoint. It'll have the log out, the registration. These are the common endpoints usually found there. But it makes our job a lot easier from an API security perspective because, okay, now we can test each one of those, and depending upon what the function is, we can test them unauthenticated. Are we still allowed to do stuff? So that makes it quite easy. The other characteristic to look for is you're going to have a scope parameter in your long query string that's going to say OpenID. So that's a dead giveaway that is running OpenID Connect. But as far as anything else, I mean, it's the same flow that we've already talked about as far as authorization code. And then the other thing about OpenID is you're going to see JOTs or JSON web tokens. So on the access tokens, they're usually in the form of JOTs. This is an example of a well-known OpenID configuration file. And you can just kind of see here, these are the endpoints. So you can see authorization endpoint. I know it's quite small, but this is just to give you an idea of what you would be looking for. And it makes testing, a lot easier. All right, so in speaking in terms of authorization code attacks, what can we do? So we're going to look at the redirect URI attack, which in essence is where we already know that the application is going to, we already know that the user is going to be redirected back to the client application. And if the redirect URI parameter is not validated correctly, well, what can we do with that? Obviously, we can abuse that. We can send it to our own attacker-controlled server, and we're going to see that in the lab. Server-side request forgery. Obviously, even in the redirect URI, we could try to do some attacks against internal servers. Cross-site request forgery. That kind of goes back to that state parameter. If it's there, if it's not there. If it's being validated, much to Cochise' question, things like that. Consent screen attacks via clickjacking. This is quite clever. That pretty much expresses what it is, but when you go to click approve or deny, if that page is subject to clickjacking. And then the reuse of that nonce, the auth code, which can only be used once, and we've already spoken about that. So what I want to do now is I want us to step through the first of the two labs that we're going to do tonight. This one in Portswigger is about hacking via the redirect URI. So I'm going to stop sharing for just a moment and get all of that set up. So give me just a second here. Okay. So the first thing I'm going to do is fire up the, and I'm just going to put this over here. Those of you following along, I don't know how I got out of my spot, but here under the OAuth authentication section, these are the two labs that we're going to be doing tonight. So I'm going to go ahead and fire this one up. And looks like I have to log in again. So I'm going to stop sharing. Sorry about that. Give me just a second. All right. Logging in and firing up. So let me share my screen again. All right. So this is our URL. And let's go ahead and take a look at what they want us to do. So first I'm going to place this here. And what you want to do is you really want to be paying attention to your traffic. So in this one, they want us to log in. So you can see the social login. They're using social media as a way of helping you to relate to the whole flow with the authorization code. So you're going to log in. And basically, each of these interactions represent the different stages that we talked about earlier. So now we're at the stage where we're saying, okay, this is the client application. We like to blog. We like to blog.com. And we like to blog.com is requesting permission from blogger.com or whatever to be able to access your blogs. And so we're going to say, oh yeah, I definitely want to share my blog stuff. So, and you can see that there's the OAuth callback. So in this particular call, we do get a code, and after that, we have to continue. So let's continue. And we should have, I'm not sure why it switched, but we should have our bearer token. So there's our code, and well, let's just look for it. So it should be here. Oh, it's here. Okay, that's right. One of these has some JavaScript code that basically places it into the authorization header. So I think I have to go here, and then I should be able to see it. So let me take my filter off. So, okay, so now what we're going to do is we're going to see the power of having our authorization already in the browser from like kind of like an SSO type feel. So I'm going to log out. And now when I click my account, I automatically get logged in because you can see here we have, and I'm going to highlight this one. You can see we have the client ID, we have the redirect URI, we've got the response type is code, and we do indeed get a code back. And then we exchange that code for an access token, which must be buried in the code somewhere. So what we're going to do is, oh, I've got to click continue. I think I keep forgetting that step. So what we're going to do is we're going to take this and we're going to send it to repeater. And what we're attacking in this particular scenario is this redirect URI. So right now the redirect URI is sending the user from, or sending this request from the authorization server back to the client application. In this case, the client application is welikeToblog.com or something like that. But what we want to do is we want to see if we can change this URL to do something differently. So if we change this, and let me just baseline just so that I have a baseline here, okay? So that's good. So I'm going to just change this to evilsite.com. And what you see is whatever I type there, whatever site I type there is reflected here in the redirect. So that means we know, okay, we have power over this. They're not validating the values or the URLs that go into the redirect URI. So what do we want to do? Well, we want to send them to our exploit server, of course. So let's go ahead and get the URL to that. And let's go ahead and set up our payload. So this is a phishing attack related to having an iframe in here. So just filling this out. So our OAuth host is going to be here. We want to put that in there if you're following along. We want to use the client ID. We want to use the exploit server's URL. Okay, so we store that. We deliver to victim. We click the access log. And look at that. We ended up getting our victim's code. So we had their authorization code sent to us, which means we can turn around and use this to the authorization server in order to get their access token. So we didn't provide the permission, they did, but we stole the code from them. So what we want to do here is I'm going to expand this. And we're going to add this. So in our stolen code, enter. Okay, I need to log out maybe. Sometimes when I do this, if it gives me that, it means it's mad at me. So we may have to do this again, but that's okay. I'm going to paste that there. Equals. Yep, it's mad at me. Okay, so we're going to have to come back to this one because what happens is I've gone into this loop before, and it, like, once you kind of don't do it exactly right, it gets upset. But yeah, step number 9, if you read it here, I was supposed to log out of the blog website before I did this. And because I didn't, it kind of goes into this wacko state. But the end of this is, if you log out and then you do this URL, you should see an admin console link. You click that, and then you delete Carlos, and the puzzle is solved. So, but hopefully, for the most part, you can now see the flow better based upon everything that we've talked about and how it relates to this. We can try it like one more time if you guys want to.
Question, Dr. Sunny?
Yes.
So if I'm trying to do this out in the wild and I want to stage my own exploit server so I can achieve proof of concept, what would I use?
I would use Collaborator if you can. If you can't use Collaborator for some firewall blocking or WAF reason or whatever, you could try, if you've got a DigitalOcean droplet, or some place that you can host, basically an external site that you can redirect to. And if that doesn't work, then your third option is to do the whole little Python server locally on just your machine, like if you're confined within the walls of a certain firewall area.
Got it. Thank you.
Yeah. All right, I'm going to try it one more time. But I think what has to happen is, let's go back here. Let me just log in. And continue. And deliver to victim. If it doesn't work the second time, I guess I'll give up. But it can be finicky. Okay, so here's the code. I'm going to log out first. Log out. Log out. Expand this. Let me get my OAuth. Code equals stolen code. There, equals. Go. Ta-da! Ta-da! At first you don't succeed, try again. Okay, so that was the first lab. I want to go through the next lab, and I may not do every single line, but the first thing I want to explain is the difference. So the next lab is stealing OAuth access tokens via an open redirect. So how is this lab different from what we just did? The difference here is, let's say that you're doing a penetration test or a bug bounty and you find an open redirect. All right, I'm going to tell you right now that a lot of bug bounties won't even let you submit for an open redirect. They don't care. They're just like, okay, you're sending it to some other place. Who cares? What you want to do is you want to hang on to those open redirects and you want to try to chain them to something that's a little bit sexier. And this is a perfect way to do it. So open redirects. So let's say you find a plain vanilla open redirect on a website. In the lab that's coming up, it's in a path parameter. So you can take that path parameter and you can basically point it to another place. But another example could be like mytrustedwebsite.com, and then there's like this return underscore URL that equals, you know, some good place. So you can tamper with that and you can send it to your exploit server or your digital droplet or your Burp collaborator. So that's just a couple of different examples of an open redirect. Not that great by itself, but when placed in conjunction with stealing somebody's access tokens, a real winner. So you get the victim to click the attacker's link containing the malicious redirect, and then you can grab their authorization code and get their tokens. So that's what this next lab is, and I'm going to go through that now. So first, let me fire up the lab. Those of you following along, it's going to be this one, stealing OAuth access tokens via an open redirect. And we're going to fire that up. Let's get rid of this. Okay, so I'm going to go ahead and log into the social media. There's that client ID again. We talked about that. And here I'm giving my approval. And this one is interesting because there's an endpoint called /me. I'm going to highlight that. That is of interest to me. I'm going to send that to repeater. I'm going to baseline. What you'll notice in the baseline is the API key of the person is there. So the goal of this whole lab is to get the administrator's API key. So if I go to my account and I log out, and then I go back to my account and I log in again, once again, I automatically get logged in. I'm going to highlight this call to the authorization server with the client ID. Send that over here. So here's the me call, the me endpoint. And here's the call that has the client ID. I'm going to baseline that. And you can see that in the response, it gives me the bearer token. So after this hash sign, you see access token, and then it equals that. Sometimes penetration testers or people in experience with APIs, they might think, oh, you always have to get a JOT. No, you don't. You don't always have to get a JOT. If it's not OpenID, you know, an access token can be anything that's cryptographically secure. So it doesn't have to be a JOT. Could be an HMAC, could be, you know, whatever they decide. The libraries support different things. So, okay, so now what we want to do is let's take a look at our solution here. The point that they're trying to make is that there's a directory traversal problem in the client application itself. So when you look at these blogs, there's this next blog. Let's just take a look at that. Next blog And that's where this path parameter is that's vulnerable to an open redirect. So you can change this to be a URL, and that enables you to send the user to some other place. So basically combining the existence of this known open redirect with trying to get the victim's authorization code, combining all of that creates this payload. And I'm going to put it in Notepad here. So it creates this payload. So basically this payload is what we're going to put in our exploit server, and it says, hey, I'm looking for that hash. Remember I showed you that hash before. You come over here. So this JavaScript says, okay, I'm looking for this hash and I want to grab everything after that. So that's what we need to set up. We just have to fill out the values. So first, your OAuth server. Let me grab that value. And then the client ID.
Hey, Dr. Sunny, could you flip the burp window real quick or drag it to the left? Because
Sure.
yeah, the for some reason the token reply is getting cut off.
Oh, okay. Thank you. Yeah. Sorry, it's right down here. It's at the bottom of it, so that's why it's a little bit hard. Can you see it now?
Let me check the comments. Oh, okay. Okay, thanks, Chris.
Cool. Thank you.
Yep. Yeah, we're good. Thank you.
Awesome. So, okay, so client ID, and let's see, grab this. Okay, we're going to redirect back to the standard lab, which is actually in the refer. So remember, this is your client application. And then, of course, we need the exploit server. That's where we're going to put this payload. Cool. Okay, so that looks good. Let's place it here. Store that. And deliver to victim. Let's look at the access log. Okay, and so this is me, right? I have redacted my external IP from the world, but this is our victim. So the victim clicked my link and I got his access token. So now that I have his access token, I can go back to the me endpoint, replace the bearer token that I used with his, click send, and now I have the administrator's API key. So we come back here and submit the answer. So that was a lot of stuff, and this is one of these things where you really need to practice seeing the authorization code flow over and over again so that you can feel comfortable with all the different components. But in essence, that's what we were going to cover for tonight. So I hope you guys enjoyed it. I hope you got some good bug bounty tips. And that's all I've got.
Excellent. Thank you so much, Dr. Sunny. I, for one, am going to be beating the crap. Like there's some stuff I want to try, especially with that the open redirect. I want to see if I can set up a listener in a C2 and see if I can have a drive-by attack occur. But I mean, I'm going to try that in my own time. I appreciate it, Dr. Sunny. you have any questions, comments, concerns, you know how to get a hold of her. Again, buy her book. With that, to all a good night.
Good night.
Have a good night.